Hello everyone. In this video I want to show you a few things that might not be super advanced, but some of you might have struggled with it and maybe never dealt with that, and now you want to do it for the first time. So I just want to go through them very fast, and since they came up in my CAD classes, I just wanted to clarify them for you. One of the first things is if you have tangent surfaces like this, so here this arc is tangent to both of these, and in reality when something is tangent like that, there is no line like this one or this one, okay? These are just showing where this one finished and this one started, but in reality there is no start and finish line, and there should be no physical line like these two. So, and not only it shows in 3D, also if you go to technical drawing and you want to create some drafts for the part, they also going to show up here and here. And if I just use one view in this case, right, which of course one view is not enough, you might say, okay, is this like for instance, a fillet or what? Right? Because if it's just these two, you can easily say it could also be a fillet. So you need this extra view to see that a chamfer. It could be also a fillet or anything else. So these lines could be a little bit misleading. So can I get rid of them? The answer is yes. So how do you get rid of them? So here I show you in 3D first in part design how to eliminate these lines if you don't need them. So you can go to view and then go to display, and then here you see tangent edges visible. If you want, you can make them phantom. If you want, you can remove them. So there we go, remove them, right? So you see now those lines are gone, and now this is kind of more realistic, and I can do a similar thing for the drafting. So again, I go to view, display, right? But of course you have to pick your view. So view, display, and again, tangent edges removed. And there we go. It is removing it from here, and you can do a similar thing for this one as well. Okay. So if you want, you can get rid of them, right? So this is regarding getting rid of tangent lines. That is automatically shown in SolidWorks by default. The other thing that is a little bit more interesting is, so if you want to make a dice or something like that, right? So to make a dice, you have a cube like this, and let's say here, let's make this number smaller because 1 is too much. It's just 4 by 4 by 4. So here you go with constant radii and basically grab all these 12 edges of the cube, right? And then if you apply a constant radius to all of them, you see that the shape is not perfectly similar to a dice. I mean, some simple dice are like that, but a little bit more fancy dices, if you look at their cross section, they don't look like that. Let me bring back those tangent lines so I can explain it better. So if you see here, this radius is kind of the same all over the edge, even at the corner. Okay, but if you go ahead and look at one of these dices, right? So here I go ahead and say dice. And if I show you an image of one of them, you can see that they kind of look like this, right? So the fillet radius is quite a bit small in the middle, and as you get closer to the corner, the fillet radius gets a little bit bigger, right? So yeah, of course, again, we have some simple ones like this, but these are CAD models. In reality, as I said, most of the time you see that a radius is kind of like this, okay? So can you make a fillet like that? That is kind of bigger toward the end. And for that, you might say, well, I use a variable fillet radius, right? You know that you can use a variable radius fillet if you want, right? Once you go to fillet, you can use this option, And here you're going to get a bunch of points along which at those points you can provide different radii, and then it changes linearly from one to the other. But clearly in this case, it is not going to be really a nice transition, okay? And because most of the time that transition is a linear transition from one radius to the next. And I tried that. It does not give you such a look. Okay, so you cannot make such a thing perfectly because it's kind of constantly changing. So you need a lot of points, and then it does it for this part. Once you do it for this part, for the other edge that is connecting to it, it starts from the point that is perfectly sharp. So you cannot control the top portion of it anymore. So making something like this is not easily possible, even with variable radius fillet. The technique to do that is actually you can use still a constant radius fillet, but there is one of the settings that we have not discussed so far in my videos, and that is this guy, setback parameters. So you go to the setback parameters, and here you can say that before getting to a corner along the edge, go ahead and start changing the radius. So here my radius is 0.2, but maybe at the corners I want to go, I don't know, to 0.7, to 0.8, to something bigger. And I want to do that basically before, so at 0.8 inch, before start increasing it. And here you have to tell it at which vertices do you want this to happen. So here I'm going to pick all of the 8 vertices of this object, and I want this to happen on all of the 8 vertices. Okay, so that's 7, and this is 8. And then here, let's even go to 1. And then if you change that, you use this button here, set all. So now all of them will go to 1. So an inch, you see this distance here, distance is 1 inch. At an inch before reaching the vertex, they start increasing at the same rate, so they all meet each other in the middle. Look here. You see that? So now if you look at this, you see here it's smaller and then it gets bigger, right? And if 1 is not enough, here I can make it even bigger so you can see the effect better. So I don't know, make it 1.5 or something, or 2 maybe. 2 may be too much, but yeah, 1.5 I guess is good. And set it all, right? And then there we go. This is how those kind of more sophisticated fillets would look like, right? Now you might say you remove the tangent faces. Are these why you still see the edges? Because here it's a little bit more complicated. So not everything is that simple tangent. So here, although there are tangencies, but the lines still might show up. So if you don't want to see it perfectly organic, click on shading without edges, okay? And this is the kind of dice that you might need. Okay, the next thing is if you have an object like this and you want to see where the centroid is, or how much is or how big is the bounding box, then you might be tempted to go here under this eye and say, well, show me the centroid. You click on here and nothing happens. There is no centroid. You might say, why? I mean, like I just say, show me the centroid. It should. You might think because it's not transparent, the centroid symbol is inside. So you might go and make it like a box or something, right? Or wireframe, and say, oh, look, again, that centroid mark is not here. So say, okay, I expected it to be here. It's not. So what's going on here, right? The reason is you have not created a centroid for this object so you can see it or hide it. The same thing goes for bounding box. If I say, hey, show me the bounding box here, right? And I activate it, good, no bounding box, because I have not inserted them yet. I have to add them, then I can make them visible or invisible. So I need to go here, say, hey, reference geometry, add the center of mass for me. Now that that option is on, I can see it. If I turn it off, I don't see it. If I turn it on, I can see it, right? Here, look. There we go. That's the centroid. You see where the centroid is? It's right there. Now, if I go ahead and get rid of this extrude, you see, it moves back to the center. When I add this extrude, you see, it moves to the right. So I can do that. And similarly, I have to go here and add a bounding box, right, for the object. And then if this option is on again, I can see it. If this option is off, I cannot see it. So this is just to make them visible or invisible, but they should exist in the first place, like here and here. And now, guess what? I can see them. So again, if I get rid of this, look, the bounding box shrinks. Okay, so bounding box and centroid, first go and insert them on the reference geometry, then make them visible or invisible. Okay, the last thing that I want to talk about is about airfoils. So if you want to make airfoils and you want good airfoils, I mean, if you looked at my previous videos about using splines, you see that, for instance, I go to some front plane and then I grab the spline tool and then I do some very approximate top spline, something like this, correct? And then I grab a bottom spline and then I create another one. I don't know, something like this maybe. And I say, well, this is an airfoil. Yeah, it is, but none of the ones in practice. The ones in practice, you have to have lots of points to pass this top and the bottom curve through. They are not defined by a few points, and the location of those points are very accurately calculated. So you can, if you want a realistic, the ones that are used in real life, the airfoils, you have to have the coordinates of those points. And the way that you pick one airfoil against the other one is based on the aerodynamic characteristics, right? Based on the drag coefficient, based on the lift coefficient, and so on and so forth. So if you are into aerospace now, I have a disclaimer. I'm not aerospace specialist or anything, but since sometimes I show how to make airfoils to my students, and some of my students are aerospace engineers, not all of them are MEs. So I just wanted to show you how to go about a realistic airfoil, the one that is in real life, as opposed to some imaginary that I made here. So one of the places that you see standard airfoils, their profiles are basically given by NACA, okay? So NACA, as you know, has a lot of these standard airfoils, and National Advisory Committee on Aeronautics. So they have a bunch of these profiles. And for instance, if you go to this website here, which is right there, here you can see all sorts of NACA profiles right here. So here is one of them. It's called NACA 0009. And here you can see, for instance, different properties about the lift and drag, right? Different aerodynamic properties here. And based on these, you can pick your basically profile, right? So you see here, you can basically see the low and the high Reynolds number and critical and lots of things. Again, I'm not an expert at aerospace and I don't want to talk like an expert because I'm not. But here, if you pick one with specific data, then in order to get the profile X and Y points of those splines, all you need to do is to go here and click on here. It says source stat file. So you go there and guess what? These are the X and Y for this profile, or and let's say Z of them are all 0. Okay, so this is what this is, that NACA 0009. Now, many of the wings have one of these at their root and another one at their tip. So they are not necessarily the same at their root and the tip. So if you get this, now how can I use it in SolidWorks? So SolidWorks has this option that allows you to basically bring in a bunch of XYZ points under curve, and it allows you to pass a spline through XYZ points. When you click on it and it's in the features, it's not in a sketch. So you don't need to go to a plane. Pay attention. You do not need to open up a sketch plane and start the sketch on a plane. It's already in 3D. You use the Features tab, not the Sketch tab. You go to Features tab, you go to Curve, you go to Curve through XYZ points, and then here you have to browse for the file. Now this file has to be either a solid curve or it has to be a text file. Now the file that here you can get from this website, if you download it, it is a .dat, it's not a .txt. So if you just right click and save it, it is actually going to be saved as a .dat file. Although it says text file, it is, but it's going to be a .dat. So make sure you save it as a .text file. So just, if I were you, I would just copy this data, open up a text document and save it like I did here. The other thing that you need to do, your data should have a Z column. So it should be X, Y, and Z. And here I assume all my Z's are 0, so all I have is X and Y. Okay, and if that's the case in SolidWorks, since XY plane, if you look at it, is going to be the front plane. So that profile is going to sit on the front plane. Now, if you want it to sit on the, for instance, bottom plane, on the top plane, then you have to make Y's to be 0 and set those data as X and Z. So you have to bring that column of 0 as the middle column for Y. Then it is going to sit on the XZ plane. Okay, so these are my data, and I saved them as a text file. So now, as I said, I can go here, browse, and then go here and change it to text file and pick this text file. You see, it already populates here, and I OK that, and guess what? Here we go. I got this profile. I got this curve. Okay, this curve is made of all of those points. I guess there were like 30, 40 points or more, probably 50 points. A lot of points. Okay, some of the more complicated ones has several hundred points. Okay, now that I have this, how can I turn this into a wing? Can I grab this curve and can I extrude it? Well, you see that if I pick my front plane, okay, you see it wants you to make a sketch out of it. Although I brought it as a curve, but I cannot directly extrude this curve. But I can project it onto any plane as a sketch, and then I can use that as sketch for basically extrusion, right? So for instance, I can go now on the same front plane, start the sketch, grab this curve, do a convert entity, convert it to a curve. Now this new sketch, which is the same as that curve, there is on the top of that. So let me hide the curve. This new sketch, which is the same as that NACA, now guess what? I can grab this and I am going to be able to extrude it, right? So there we go. And I don't know, 6 inches, 10 inches, something like that. There we go. Okay. So here is what? Here is a wing with no draft angle. Again, in reality, that's not the case. The other side is typically a different one. Typically at the roots, this is a smaller profile. At the tip, at the root is a bigger profile, and when you bring one of them on this plane and project the other one on an offset plane, which is as it's away as much as the span of the wing, then you can use a multi-section or a loft and connect them together to get the more realistic wing profile. But this is how you bring NACA profiles as XYZ text files in SolidWorks and get a realistic wing as opposed to just making it up with a few points. So hopefully the summation of all these points that I told you help you with your SolidWorks design, and I'll see you in the next lecture. Thank you.